Right, now this is an exercise where we try to draw a two-way table from a tree diagram and then use that to find a conditional probability. Right, now here is the tree diagram, and there are two events here, and the first event is that of testing, and the second event is to find out if you're ill or you're not ill. So to complete the tree diagram, to start with, we need to make sure that each branch adds up to 1. So if we start from this one here, you need to add 0.85 to 0.15 to give you 1. And this one, you need to add 0.8 to 0.2 to give you 1. And here, we add 0.95 to 0.05 to give us 1. Now, if we test positive and then have the illness, that is P intersection L, okay, and that is going to be 0.2 times 0.85, and the answer is 0.17. And if you then test positive and do not have the illness, that will be 0.2 times 0.15, and that should be P intersection L prime. Moving on, if you tested negative and then have the illness, that will be N intersection L, N for negative, intersection L, and that should be in this box here. And finally, if you tested negative and do not have the illness, then that becomes N intersection L prime, and that's there. And just to check, if you add 0.174 P intersection L and 0.03 for P intersection L prime, you get 0.20. If you add N intersection L, which is 0.04, plus N intersection L prime, which is 0.76, you get 0.8, and that tallies with what is given in the tree diagram. And just to check again, the marginal probability row is 0.20 plus 0.80, and you get 1, and the marginal probability column is 0.21 plus 0.79, and you get 1. Moving on, we want to find the probability that somebody chosen at random has a positive result and has the illness, and that's going to be 0.2 times 0.85, and we have 0.17. Moving on, again, the probability that you're going to have the illness, and this time around we look at the L sample space, that's the illness sample space, and that will give us 0.2 times 0.85, which is 0.17, plus 0.8 times 0.05, which gives us 0.04, and if I put 17 to 0.04, you have 0.21. Right, next, incorrect result. Now, if you test positive and you're told that you've not got the illness, now that's incorrect. Or if you test negative and you're told that you've got the illness, that is also incorrect. So the answer is 0.03 plus 0.04, and that should give you 0.07. Moving on. Now, we've got in the town 10,000 people in the town, and we want to estimate the number that will be told that they have the illness. Now, presumably, if anyone tests positive, he or she will be told that she got the illness. So the number is going to be 0.2 times 10,000, and we're going to get 2,000. On the other hand, if you actually, for the actual illness should be the L sample space, and that's 0.21 because 0.17 plus 0.04 is 0.21. So if we want to estimate the number that we get the illness out of the 10,000, we multiply 0.21 times 10,000, and the answer is 2,100. Now, I've made up some questions myself to do with conditional probability. Now, if we're looking at the positive sample space, if somebody tests positive, we want to find the probability that this person will be ill. So we ignore everything else. We're looking at the positive sample space. And if you test positive, the probability that you will be ill will be 0.17 divided by 0.02, and that's 0.85. On the other hand, stay with the positive sample space. If you test positive, the probability that you do not have the illness is going to be 0.03 divided by 0.20. And this time around, if we look at the illness sample space, the illness row, if you're ill, the probability that you tested positive will be 0.17 divided by 0.21, because we're still working with the illness sample space, the L row. So if you're ill, the probability that you actually tested positive is going to be 0.17 divided by 0.21. Now, I've not finished it all, but you can do some yourself. Have a look at the L prime row, the L prime sample space, and see what you get for conditional probability. I hope that has been interesting. I'm sure it's a bit too long, but please get in touch and let me know how you feel. Thank you for watching, and goodbye. Have a good day. Bye-bye now.